today we'll be looking at how to draw the reflection of waves for three types of wave, which is water, light, and sound. So first off, you need to identify what kind of wave do we draw. For water, it is always drawn as wavefront. And for light, it will be drawn as a ray, just one straight line, like you've learned in the light chapter. And for sound wave, will also be drawn as a wavefront. And another thing that you need to identify is that here, when we look at this whole picture for a water wave, you need to be able to notice that this is how it looks like in a ripple tank. So what you've got here is wavefront. So all these lines are wavefront and circular wave as well. And what you've got over here is the reflector in the water of that ripple tank. Okay, like you can see here, these are the wavefront just now, and this here is the reflector. So we're basically drawing it in terms of how it looks like on the screen. So the wavefront and also the reflector, which is drawn. Okay, so let's get back to this. So first off, we want to have a look at the step-by-step that you need to take when drawing these waves. So let's look at water waves first. So these are the steps. So step one, what you need to do before you draw the reflection of wave, how it looks like, is to start with drawing the normal line. Okay, so I'm just going to show you an example for one picture, this one, before we go on with the next. So I'm going to use red color to draw the normal. Remember that normal is 90 degrees to the surface. So now I'm trying to make it. I've put on the lines on this ruler exactly parallel to the surface that we have. And I'm going to start to draw the normal, which usually will be represented by a dotted line like this. So that here is the normal. And then the second step would be to draw the reflected line. Okay, so in this case, if it is in real situation, whereby in real exam, then you have to use a protractor to measure the angle here, and when you draw your reflected ray, it has to be the same angle with that. But because I don't have the tool here, so I'm just gonna do a little bit of guessing. So it must have looked like somewhere here as the reflected ray. So now that purple color will be my reflected ray. Okay, and it's written here, making sure that I is equal to R. In real life, please use protractor. And then in step 3, the next step would be to draw the reflected wavefront. Okay, so remember that wavefront is always 90 degrees to the direction. For instance here, this line here is the direction because it got an arrow. And this here is the wavefront, so it will be 90 degrees to this direction, like at all time. And that's how it's gonna be for our picture here too. So I'm gonna take my ruler again and make it 90 degrees to my line. Just gotta make sure my scale there touched it, and I can start drawing. And when I draw this wavefront, I just gotta make sure that my wavelength is the same as previous, because wavelength doesn't change. Usually for SPM, 3 lines is enough, but I'm just gonna add one more here. just for fun. Okay, so that's it. That's how you draw the reflected ray. So now I'm going to go about drawing for all of the situation that we have here, okay, by using the same step. So let's start with this. Okay, remember that I will use a red color for my normal. The normal is 90 degree to the plane. I'm going to start drawing normal for everything first. So this is all my step 1. The normal for a circular shape is always at the middle. We'll cross out its center of curvature. And now on to my second step, which is the reflected ray. In this case here, it will be reflected exactly the way that it come from, because it's coming in a straight line. Okay, so now I'm done with all of the second step, which is the reflected ray, drawn in purple here. And now I'm gonna draw the reflected wavefront. So as you can see for the first one, it's just going back the other direction. So the wavefront should also be still 90 degree to that line. So I'm gonna draw with a green this time, just to make sure it's obvious. So like I say, what required from you is just 3 lines, but I'm just drawing a little bit more. Okay, so that will be the wavefront going backward. And for circular wave, the wavefront going backward will take on a slightly different shape. 3 is enough, so I've drawn 4, so that's enough. And the next one is this one. Also, we'll be going back in a motion of a curve on a different side. Just got to make sure that if your curve is not, you just got to make sure that your curve looks a little bit like the previous curve, and that its wavelength is roughly the same as the previous as well. So the examiner will not be too strict in terms of that, as long as you know the shape and you can tell that roughly by looking through the eye that the wavelength is the same and the shape is the same, is a curve. Okay, and then all of these other ones, basically when you have a curve like this for a reflector, the shape of the wave are going to slightly change. So we're going to have a look at the first one, which is a plane wave approaching a curve that looks like this. Okay, and when the wave is reflected back, the curve will follow the shape of that reflector. And then for the next one, when you have a curve like this, and the shape of the wave, the circular wave that hits it is the same as it is, when it is reflected back, it will become a plane wave. You should use ruler, but I just want to be quick here. And then the last one, when it comes in with this kind of shape, it will follow the shape of the curve again. So that's how it's gonna look like. So now I'm gonna have a look at like. So this is pretty easy because you've done this before. So you just gotta make sure that I is equal to R, and then you basically get your reflected ray. Okay. I've already done the first step for you here, which is drawing the normal. Sometimes in exam or in question, it is not given to you and you have to draw it yourself. So this is the normal line here. Okay, the dotted line. And then you just have to draw the reflected line by making sure that I is equal to R. Use protractor. And then the last one would be for sound wave. Okay, so sound wave also, the first step is to draw the normal line. And then you have to draw the reflected line. But sound is always represented as a wavefront, and it always represented as a circular wavefront. So in this case here, the incoming sound will look like that, and an outgoing one, which is reflected, will look like that. Okay, and I equal to R. Okay, so it's water waves, and they also give you the frequency. And question A1 wanted you to draw the direction of propagation, and then they want you to compare the wavelength and so on and so forth. So you can try out the question, pause the video, and come back later for the answer. Okay, so to draw the direction of the propagation, remember, first step is to draw the normal. So in this case, the normal is already drawn for you here. So in actual exam, what you do next is you use a protractor and you measure this angle here, and you also use that protractor again, make it the same angle of reflected here, so it's 45 degrees. So that's the reflected ray, and don't forget to draw the direction, and then your wavefront will be 90 degrees to it, and make sure the distance is the same. Like if you can measure here, it's around 1 centimeter. So I'm gonna make my wavefront around 1 centimeter too, and again 3 line is enough. Okay, so that's your answer for A1. And then A2 is compare the wavelength and the speed of the waves before and after the hit. So this one is unchanged, or you can also write the same. And the clue is given here because it's just one mark, but they ask you about both speed and wavelength. And then question B, we haven't learned this yet because it's in sound, but however, I'm just going to give you some of the answers here. So some of the modern technology to detect the souls of fish, because this one is in terms of the reflection of sound. So you can use sonar, for instance, because the question is about reflection, right? And then 2 reasons why this is used instead of conventional sound. So you can give, the first reason is because it uses ultrasound, which means your ear can hear it, or outside of the range that a human can hear. And then also because sound wave have high energy because of the high frequency. Okay, ultrasound. All right, so that's it. That's the answer for this question. So now we're going to have a look at the summary, what we've learned today. So first off is drawing the reflection. So we've learned about water, light, and sound. Just remember that this is drawn in a form of wavefront. Light is in terms of ray, and sound is in terms of wavefront. Then you just gotta remember the steps, right? And then that's it. That's what we've learned today. Alright, till next video.